Hey guys, welcome to the next tutorial of ethical hacking and penetration testing by Kali Linux. So in this tutorial we will be learning about port stealing and how it works exactly. So this attack exploits the vulnerability of switch devices in a LAN. It cannot be done on a wide area network because we would be using internet, but if you have already gained access to the network, then you can go ahead and use a remote computer to go ahead and do all of these stuff. So it consists in forcing a switch to update its forwarding table so that it will forward the packets sent to the victim on the port to which the attacker is connected. So I understand that this might be a bit confusing, so I'll just go ahead and simplify this out. But before I proceed, let me show you some important port numbers and let me tell you how exactly it will work. So I'll just go ahead and type important port numbers first, and let me tell you what these things do exactly and how it works. Start, and by the time it starts, let me go ahead and open my notepad. I'll show you some important notes, and mine it is down, I believe. Let me check. Okay, perfect. So these are the important ports. 443 is the most important, and most of the time when you go ahead and try to hack into something, you will find all of these are except a few, like two or three things, two or three port numbers, everything else will be blocked. So this is the network time protocol. This needs to be active all the time because it gathers network information and the date and day and everything from the internet. After that we have 443, which is the SSL protocol, and without this you will not be able to access the internet. So the person whoever is managing this should make sure that the firewall does allow incoming connections, but only restricted incoming connections. And then we have the 500, that's the important one, that is the inter-key exchange IPsec protocol, and which is quite important. So these are the important. So just think that if any of these things are compromised, then what may happen? Let's say for example, if the network time protocol is open and we have this port access, so you can go ahead and modify the network changes, and trust me guys, any kind of changes to the days and date can go ahead and create a hell lot of difference in the system management and everything for an administrator, and that will not be good. After that we have the HTTPS 443 port over here, and this is most of the time open, and hackers normally go ahead and use this port or the port 80, that is the HTTP, because it is not that secure. If the person knows how to go ahead and strip off the SSL, he will use the port 443, because even if the attacker is going ahead and using the port 443 to go ahead and hack into something, and any outgoing traffic from that computer, the administrator will most of the time they go ahead and just ignore that part, because 443 usually goes through the secured strip line, and they won't even be able to know what exactly is going on, and they will think that since it is secure, it will be any part of the computer and not the attacker. So let's go ahead and start. Let me check if I could go ahead and run there. Let me check. Okay, so netstat does not work, or I'll have to run it through administrator, I believe. Perfect. Okay, and so let's let this start. So as you can see, the last numbers are the port numbers as to where exactly it is going. So port numbers work in this way. I have taught this previously, but again I will go through them. So it works in this way, like let's say for example, you're ordering something through Amazon or any other website or eBay, let's say for example, then they will ask you to go ahead and input your address. So you will put address like something, let's say for example, America, and you will type California, and you will type West Edmonds Road, and now West Edmonds Road, and give me any random name. Let's say Cali Hill would be the name of the building, and finally the number 45 or 46, whatever the number would be. So Cali Hill, so what it is exactly is, this is the building or the locality where you live. This is your house's number, and this is the road, and this is the area and everything. Normally we don't need the exact city or country, and so this is how it works. So how port stealing will work is that this will be ISP. After that we have the you can say as, let's say for example, let me just go down and cut it out, the internet, where exactly it is, and we have the ISP, internet service providers, and then we have the IP address, then we have the MAC address, and finally we have the port number. and actually we don't need the MAC ID because it would be the same. Perfect. So California is the internet from where exactly it comes, and then we have the West Edmonds Road, that is the area, that is the ISP, which area we are on exactly. The IP address would be the specific area where we reside. So IP address can be multiple people can have same IP addresses, and you may have heard that a person has same IP address, but trust me guys, multiple people do have the same IP address, but they the ending may be different, or the ISP may be different. That's the reason they to make it more simpler, let me tell that one internet service provider cannot have the same IP addresses, but multiple internet service providers can have same IP addresses. That is the best I can go through. So whenever you go ahead and send some data from your computer, and when it comes back to you, it will first check the internet connection, then the ISP provider to where it should go, that is the road, and it is same like the courier facility. Then it will check the IP address inside the ISP, that is your area, and finally it will go and check the port, that is the door, that is your only, and that cannot be different for any person, and only that thing will go through that port. This is how the port stuff works exactly. So normally the the administrator won't even go ahead and recognize that you are the one who is actually going and trying to steal something from them. So that's how it works. And now let me teach you how port stealing works exactly. So the attacker can receive the packets and read the contents once it has switched to update its forwarding table. And port stealing is a kind of attack where someone steals traffic that is directed to another port of an Ethernet switch. So this attack allows someone to receive packets that were originally directed to another computer. It does so by making the switch believe that the attacker's port is a correct destination of the packet. So understand port stealing, you have first to understand how Ethernet or the Ethernet switches in particular work. First, there is a MAC address, which is a unique address for each and every computer that is connected to the Ethernet network, and that is recorded in a network adapter. Ethernet frames have two MAC addresses stamped to it. One is the source address, which identifies the computer that sent the frame, and other one is the destination address, which is the address of the computer to which the frame has to be delivered. In the early days of Ethernet, like in the mid-90s, all frames were sent to everyone using a shared media such as coaxial cables, so everyone could listen to all the traffic. And this had several problems, security being the most important of them. Ethernet switches improved the situation by segmenting the network in such a way that every computer now has its dedicated port, and only the person that wants that specific packet will be directed towards itself, and no one else will receive that. So an Ethernet switch is able to learn who is connecting to the port, and it does so by listening to the port traffic. As soon as your company sends an Ethernet frame, any frame, the switch looks at the source address and records it to an internal table. When it receives a frame that is destined for your computer, it sends the frame only for you. The computer in other ports don't receive the same port, and once you understand how it works up to this point, the port stealing attack becomes very easy to understand. An attacker is connected to, let's say, the another port. As you can see over here, this is the attacker's port and this is the original port. And as such, he's blocked from watching your traffic. So the attacker won't be able to watch you are doing exactly, continuing MAC address as the source address. So he will go ahead and impersonate your computer, and the switch gets confused, which is actually the real one. The switch usually transfers the frame to the last port, which appeared to be the owner of that MAC address. And if the attacker is sending lot of frames, he's going to receive your frame in place. So let's say for example the MAC ID. Let's say for example, I'll take a random. I will not even name it a specific MAC ID. To make it more simpler, I will just tell that, let's say for example the MAC ID of this computer is A, and for this computer is B. So what it will go do is that it will go ahead and spoof its MAC ID to A, and then it will go ahead and DDoS this machine, that's denial of service attack to this machine, or distributed denial of service attack, so that it will go down and it won't be able to go ahead and connect to this computer, the original hub or the switch. And later on, when the switch sees multiple addresses stating that, it will see that there are multiple addresses, the MAC address of both, but it will not be able to go ahead and it will be confused to which it should send to. So it will go ahead and send it to the last used port, which is this actually. But it will not be able to send that, the reason being that the port is already blocked by the DDoS attack. So then it will be forced to go ahead and send that packet to this computer, and then he will go ahead and impersonate that computer, and he will have all the information. So the switch usually transfers the frame to the last port, which appeared to be the owner of that MAC address. And what happens next on is depends on the attacker's intention. He may receive your packet and keep it for himself, but he can also send the packet back a few moments later so you receive it with a little bit of delay, and you have no way to tell that it was compromised. So port stealing rely on the fact that the switch needs to update its address table dynamically, because real networks are not completely static. For example, if you move your computer from one port to other, you would expect the traffic to be sent to the new port instead of the old one. However, there are some more advanced configuration that you can apply to a switch in order to make this kind of attack harder to do. These features are typically of the more expensive enterprise grade, and switches are not found in the less expensive small business equipment. It's typically found in the most companies and homes, which makes these environment more vulnerable. But at the same time, this isn't a very useful attack for all small networks, because it involves a lot of work to do and to capture a small amount of traffic as well. So that's how the port stealing actually works in reality, and using it is quite easy rather than just going ahead and knowing how it works. So once you know how it works exactly, it will be far easier for you to go ahead and implement that. So that is it for this tutorial. In the next tutorial, I'll be teaching you about the most important ICMP redirection, and finally the traffic tunneling. And once you have all the basics right, it will be easier for you to understand how the ICMP actually works and why it is very bad. So that's it for this tutorial, guys. See you in the next tutorial.